Good morning, guys. So this first video that I included in today's Edmodo assignment is actually the type of problems that I looked at for those people who attended the Zoom session on Tuesday. So if you attended the Zoom session on Tuesday and you were okay with that, you might want to skip this video and then go on to the other two that I attached to today's lesson. If you didn't go to the Zoom on Tuesday, it's probably to your benefit to take a look at the couple of examples that I'm going to go through. So on Tuesday, we talked about the steps for solving systems of equations by graphing. And here is an example of a systems of equations. Notice that you have two equations that may or may not be in slope-intercept form that you are going to graph on the same coordinate plane. Our goal is to see what the point of intersection is, and that is called our solution. So for this first equation, y equals 1/2 x plus 5, we have an equation that is in slope-intercept form already. Remember, slope-intercept form is y equals mx plus b. So I can see that my slope is 1/2 and my y-intercept is 5. So when I go to graph this line, I'm going to plot my y-intercept first. From there, since my slope is positive, I'm going to go up 1 and to the right 2 a couple of times. And then I'm going to go back down 1 and to the left 2 a couple of times to get points going in the opposite direction. Once I feel like I have enough points to form the line, I'm going to connect them. I'm going to make sure I have arrows at both ends. And the last step is to write my original equation, y equals 1/2 x plus 5, on the line. So in the past, couple of months ago, we graphed linear equations on coordinate planes, and we were only responsible to graph one line. So the difference here is that we're going to now graph a second line. So if I take a look at my second equation, I have x plus y equals 2, which is not in slope-intercept form. So I need to decide what needs to be done to get that y by itself. Since I have a positive x on the same side as the y, I'm going to subtract x on both sides. That leaves the y by itself. And I always want to put it in slope-intercept form. So I'm going to put my x term, which is negative x, followed by my constant, which is positive 2. So I can see that my slope, the coefficient of x, I have an imaginary negative 1. I'm going to write that as a fraction. And my y-intercept is a positive 2. So I'm going to plot my y-intercept first on the y-axis. My slope is negative, so I know I have to go down 1 and to the right 1 to get to the next point on the line. Heading down and to the right is not going to get me to cross over the other line I already graphed. So I'm going to go back to my y-intercept and I'm going to move in the opposite directions. And I'm going to go up 1 and to the left 1. And I can see right here where I plotted a point that was already there. That's going to be my solution. So let's graph this next line. Write the equation on it. And we want to write the original equation, so x plus y equals 2. And I also want to identify that solution. That's the whole point. Okay, if you notice the very first thing it says at the top, it says solve the following system of linear equations by graphing. So the whole point of this is to find the solution, and the solution is that point of intersection. So negative 2, 4 would be the x and y value for that ordered pair. All right, so just to go through a little bit of vocabulary, a system of linear equations is formed by two or more linear equations. Usually in 8th grade, we don't graph more than 2 lines in the same coordinate plane. The solution of a system of equations is an ordered pair, so a point that satisfies each equation in the system. And we're going to go back to what that means. And this ordered pair is known as the point of intersection. Okay, so our point of intersection is the solution. What it means to satisfy each equation. If we were in the classroom doing this, our very last step would be to do a check. And the way we do a check is just like we've done in the past with algebraic equations. I would take each of my original equations, y equals 1/2 x plus 5 and x plus y equals 2, and I would substitute in those values that I just got for the point of intersection. So my x's would be -2 and my y's would be +4, and I would substitute those into each equation and do a check. So for my first equation, I have 4 equals 1/2 times -2 plus 5. So the left hand is 4. If I substitute the right hand side into my calculator, I am going to get a positive 4 as well, so that checks. And on the right hand equation, I have an x value of -2, a y value of 4. And again, if I simplify both sides, I would get the same value on both sides. So the fact that my check on the left worked and my check on the right worked, that proves that -2,4 is definitely the solution. So when it says that it satisfies each equation, that's what it means. It's just kind of a fancy way of saying that your check works out for both equations. Okay, let's take a look at another one. Let's say we had y equals 1/3 x plus 1 and x plus y equals 5. I can see that my slope is 1/3. It's already in slope-intercept form. My y-intercept is +1. So I'm going to plot +1 on the y-axis. The slope is positive, so I'm going to go up 1 and to the right 3. And I'm going to go back to my y-intercept and go down 1 and to the left 3 to get some points going in the opposite direction. I'm going to graph my line, make sure there are arrows at both ends, and then finally write that equation on the line. Okay, my second equation, x plus y equals 5. That is not in slope-intercept form. So again, similar to what I did in the first problem, I need to solve for y. So to get rid of that positive x on the left, I need to do the opposite and subtract x. That will get the y by itself. And I'm going to put my x term, -x, and my constant +5 in that order from left to right. I can see that my slope, the coefficient of x, I really have an imaginary -1, so I'm going to put that as a fraction. And I have a y-intercept of +5. So first point I am plotting is +5 on the y-axis. From there, my slope is negative, so I'm going down 1 and to the right 1. And I'm going to keep going until I cross over that line. And once I cross over that line, I know that I found my solution. So I'm going to form my line through these points. I'm going to write my equation on the line. And I want to identify that solution. And that ordered pair would be at 3, 2. Okay, if I take a look at one last problem, we have y equals x plus 15, which actually I'm going to change this because I can't fit 15 on that coordinate plane. It only goes up to 10. So why don't we make this equation y equals x about x plus 3. Okay, so these are both already in slope-intercept form, which makes things easier. So I have a slope of 1. I'll make it a fraction, a y-intercept of 3. So I'm plotting 3 on the y-axis first. Positive slope, so I'm going up 1 and to the right 1. And then to get points going the other way, I will go down 1 and to the left 1. I want to make sure that I extend my line in both directions so I can see exactly where this line falls across the coordinate plane. I'm trying to move my line over, but it's not working. All right, we're going to have to leave it like that. You know how picky I am. That line should really be going through all of the points, but for some reason, I can't seem to choose that line. All right, so I'm going to leave it alone so I don't mess up the rest of the graph. My second equation, y equals 4x. We have a slope of 4/1. And then remember, my y-intercept comes after the x term, but since there's nothing there, that means I have a y-intercept of 0. So from 0 on the y-axis, I'm going to go up 4 and to the right 1. Since both of my numbers are positive, I have a positive slope. And I can see as soon as I plot that first point, that is going to be my solution. So I'm going to use my ruler. I'm going to graph the line. And I can see that I have a solution right here at 1, 4. So 1, 4 would be my solution to the system of equations. Okay, so that was basically what I did during the Zoom session on Tuesday for this part of the new work. So hopefully you got a little bit of an idea of how we're going to do this. We're kind of taking stuff we've learned already in the past and just kind of piecing it together. The second video is going to be a couple of additional examples, so especially if you weren't at the Zoom session on Tuesday, and even if you were, I would definitely take a look at those examples. And then the third video just goes over one of the systems on IXL and just shows you how you're going to be graphing that on IXL. All right, so if you have any questions, let me know. I will be happy to answer them. You can just send me a snapshot or send me a message, and I will get back to you as soon as I can.